In this video, we'll decide whether the krypton-fluorine bond is polar or nonpolar, and then determine the fluorine-krypton-fluorine bond angle in krypton difluoride. First, a quick idea. Bond polarity comes from electronegativity differences. If the difference is large, the bond is polar. If the difference is zero or very small, the bond is nonpolar. Let's visualize the krypton-fluorine bond and compare electronegativities. Fluorine is about 3.98 on the Pauling scale, and krypton is around 3.0. So the difference is about 0.98, which is bigger than about 0.4 to 0.5, our typical nonpolar cutoff. That means electrons are pulled more toward fluorine, making the bond polar. So the krypton-fluorine bond is polar. Let's answer the question. The krypton-fluorine bond is option A, polar, or option B, nonpolar? The correct answer is A, polar. Next, the fluorine-krypton-fluorine bond angle in krypton difluoride. We'll use VSEPR theory. Count valence electrons, draw a Lewis structure, then infer the shape. Krypton has 8 valence electrons. Each fluorine has 7. Total is 22 electrons. Make single bonds to fluorines that uses 4 electrons. Complete fluorine octets with 12 electrons. 3 lone pairs remain on krypton. That makes 5 electron domains around krypton, 2 bonds, and 3 lone pairs, and a X2E3 pattern. Electron geometry is trigonal bipyramidal, but the molecular geometry is linear because the 3 lone pairs sit in equatorial positions, pushing the 2 fluorines axial and opposite. Let's build a quick VSEPR picture. The 3 lone pairs are in the equatorial plane at 120 degrees to minimize repulsion, and the 2 fluorines are axial, straight up and straight down from krypton. That makes fluorine-krypton-fluorine a linear 180-degree angle. Now choose the fluorine-krypton-fluorine bond angle. A, 90 degrees. B, 120 degrees. C, 109 degrees. D, 90 and 120 degrees. E, 180 degrees. Correct is E, 180 degrees. Summary. The krypton-fluorine bond is polar because the electronegativity difference is about 0.98, and krypton difluoride has a linear shape with a fluorine-krypton-fluorine angle of 180 degrees.